The nervous system is proceeded with the reflex arc, where a receptor generates the nerve impulse. The nerve impulse is transmitted by a sensory neuron, which takes message to the central nervous system. However, this process is not that simple. It contains several steps that are required for the message to move along dendrite to cell body to the axon. In other words, the step of neuron to neuron. The impulse enters through the dendrite first, and if there's enough impulse, it will fire through the cell body into the axon. This is called the all or nothing factor.
Let's zoom into the axon and see how the action potential actually works. At resting potential, the inside of the nerve is more negative and the outside is more positive. Sodium is found on the outside of the axon, while in the inside you can find potassium.
First, the sodium is depolarized through facilitated diffusion into the neuron through sodium channels that open up.
Once the sodium enters, the next sodium channel opens. As the depolarization process moves forward, a new channel opens and allows the potassium to leave the axon.
After the potassium leaves, the inside of the axon becomes positive and the outside is negative.
After the refractory period, it'll go back to resting period until another impulse is fired. As the impulse keeps moving across the axon, you'll reach to a place called synapse.
The arrival of a nerve impulse causes the calcium ions to enter the axon bulb, which also then causes the vesicles to fuse with the presynaptic membrane.
When the neuron transmitter exits, they will diffuse across the synaptic cleft and bind with the protein receptor. However, if there is drug involved in the body, it will block the protein receptor like a protein inhibitor. Since the drug is bind to the protein, the reaction rate will decrease. This will then significantly affect the reaction speed of the nerve impulse.